It is the same question, but this time I'm going to solve this question slightly different in a different way. Instead of looking at the particles A and B individually and plotting, drawing the free body diagram for A and B, I will concentrate on the whole system and put the free body diagram for the whole system now. For the whole system. So it's quite tricky to identify the forces acting on the whole system, or it's tricky to put the directions, let's say, in x and y coordinates, because if you look at the system, it is done on a horizontal plane, and I will consider the whole system as, let's say, rotating or trying to rotate in a way that it's moving in clockwise direction, or forces trying to stop this clockwise motion. Because if you look at B over here, because of component of weight, this system has a tendency to move or rotate in the clockwise direction if you consider the whole system. What do I mean by the whole system? Is the connected bodies. So both of this system, imagine this system as the connected, so both of these ones. So I'm not going to consider the tension within, that is, I'm not going to look at the tension individually. I'm just going to look at the whole picture. Now if you look at the whole picture, there is one force trying to push this system or trying to rotate this system in the clockwise direction, and that is the component of weight over here. Remember, we have found the component, this is weight and this is 30 degrees, therefore the component of this weight trying to push object B is W sine of 30. And this is the force which I will place it in the free body diagram for the whole system, which is W sine of 30. So this is the force which is trying to rotate this whole system in the clockwise direction. What are the forces, do you think, are trying to oppose this motion? So if you look at the force of friction acting on B, this is acting in the whole system actually, because this is the force which is trying to oppose this motion, as well as the force of friction between A and the ground over here as well. So force of friction Fa as well as Fb, both of them are trying to oppose this motion. Therefore I'm going to put these as Fa and Fb are trying to oppose the motion of the whole system. Tension still is not in the picture. That's the most important point that you should understand when you look at the whole system. Are there any other forces acting on the system, trying to rotate this system? I guess not, because this is a horizontal plane, therefore the component of weight is nothing to do with the motion so far. So now here is the net force. I'm going to write net force is equal to mass of the whole system times acceleration. Net force will be W, which is WB sine of 30, minus force of friction acting on A plus force of friction acting on B is equal to mass times acceleration. Now I will keep M as M because both of them is 40 kilograms. That is mg sine of 30 minus, what is Fa? It is mu times N plus, this is Na, mu times Nb, which is equal to M total times acceleration. I carry on, mg sine 30 minus mu is 0.15. Normal force acting on A is mg plus 0.15 times normal force acting on B is, remember we have done it last time, mg, it is this one over here, that is W cosine of this angle, which is W cosine 30. So that is mg cosine of 30. It will be equal to, what is the total mass of the system? Is 2m multiplied by A. In here, if I continue solving this equation, sine of 30 minus 0.15 mg minus 0.15 mg cosine of 30 will be equal to 2ma. Again, we got m in every expression over here, so I can cancel it out. Let's solve this equation to find acceleration again and see if we are going to get the same answer. 9.81 sine 30 minus point. And when you do this calculation, you are going to get A as 1.1 meters per second square, which I have already found in the first part. By looking at the whole system, you can easily find acceleration so that you don't have to insert tension into the other equation, and it looks like this calculus or the algebra of this problem becomes a little bit easier, whereas you cannot find tension by just looking at the free body diagram of the whole system. So you still have to go back to one of these objects and you have to identify which one is you think is easier to find tension by looking at A or B, and then you have to solve the question to find the tension. So in this case, since this B is lying on an inclined plane, I think it's quite difficult to find out the tension. So I will look at A in here, and I will put the free body diagram for A to solve tension. Now, if you put the weight downwards, normal force acting upwards, tension is acting to the right, and the force of friction A is acting to the left. Again, I'm going to write net force is equal to mass times acceleration. Net force in this case will be tension minus force of friction is equal to mass of A, not the whole system, it's only mass of A multiplied by acceleration, which I found it. Tension I don't know. Force of friction is mu times NA. Mass is 40 kilograms. Acceleration is 1.1, which I found it over there. Tension minus 0.15 multiplied by normal force is mg, which is quite easy to find, I guess. Let's solve this for t and find t right now. 40 times 1.1 plus 0.15 times 40 times 9.81, that is going to give you tension as 103 newtons. Good luck.